Okay, I haven't made a video in a minute, but we've been working on this door and the other door. So this is the frame put together for the lift slide that goes in this hole, which we're working on right now. And, oh look, there's my pencil. I was wondering where I left that. I was shimming this plumb and level because I put it together and it's got adhesive in the joints that's curing. And when I screwed it to the wall, I wanted it to be nice and square while it was resting for tomorrow. And this one is in, they're the same door basically. And we brought our air barrier from the outside of the eye joist, or the outside of the sheathing, in, and we attached it all the way around the door, and we packed the gap with mineral wool, which is really nice. We ran out of this awesome tape. It's a Sega tape, and it's got this side of the tape is already released, and you peel the backer off of this side, so you can stick it on and then peel it. I really like that one. There's a lot of enjoyment. And then you can see some of our shims down here. They don't look super fancy, but this sill is rock solid. And it's a 2x12 under here. And then we packed it with mineral wool, and the inside is going to get finished out later. I know this is not a high-end building material, but this Protecto wrap came from Home Depot, and we put it out in the sun and got it nice and warm, and it ended up sticking really well. So I'm kind of okay with that. That's covering our 2x12 on the outside for snow melt, as my architect friend said we needed, which I really appreciate. And then all this Adhero on the outside here and this Tescon is weather resistant barrier, and also to prevent wind washing of our mineral wool that's around the door up here. And then it's extra thick here because there's some fastener holes. Oops. It's extra thick here because there's some fastener holes that need to get covered. And then fastener holes all the way up the side for the fixed panel. The fixed panel has a tongue in it, and it goes into this dado here, and we put some spooge on it and taped it all the way around. My friend says spooge is a real word. Yeah, so this door is good to go. It's up on its rollers now, obviously. And then when you're ready to set the door shut, you set it down, and it squishes these gaskets, 3 gaskets on the bottom, and makes an air and watertight seal at the bottom. And then it also latches. You can see this movement here. It hooks like onto this bolt here, which squeezes it shut as it goes. It makes a little satisfying clunk sound when you let it down, and it squeezes onto the bolts. So all these windows have a squeeze function to them. We had some windows upstairs here that are, I hope I don't die on this ladder on video. These were kind of a first here, an angled tilt turn. I don't have my key with me for this square, but this is the turn version, but it's got an angled top on it. There you go. Angled top. And then the tilt version is like this. So, oh look, I put the handle on this one. Somebody put the handle on this one. So this is the tilt version, but angled top. I think they said, Enersign said it was 10 degrees tilt on this one. Yeah, so pretty cool stuff there. I've never seen a angled tilt before. And that ladder is super sketchy. I need fall protection to go down this ladder. It's the sheetrock pile that makes it so terrible. Okay, I made it. I should put this one up there. So out here, we're working on the foundation. Again, it's similar to the one over there in the office, but we bolted the ledger on with these giant Blast screws. Sorry about the banging. And then we're filling in the gaps, and then we're gonna put this 2x12 on top of it. This one over here is still a problem, but I'm working on it right now. So, working on a strategy for fastening it. I can't get to the inside to screw it in some blind holes. So I got some brackets here. So there's about 1.75 inches of foam filled plastic here. And then like these screws right here, they go into the wood frame, the actual wood frame. So I got some long screws here and I went through the plastic and embedded them in the wood frame. So I'm gonna try that. I've been bagging it around and trying to get it plumb, which has been tricky. So I got a L90 here on the top. My gap is a little larger, so we're gonna do L90 on the top. But what I'm working on right now is we set up a laser and shot a plane all the way across the door here at the bottom to make sure we're not bending it like this or like that, because the giant glass door panel will not work in that bendy bit. But after I put the 2 screws in over here, this is no longer level. So I can fix it, but I don't know if I should take the bottom out or the top in to maintain my plane. So we're gonna have to find some more batteries for the laser and set up the plane again and try and measure it in the sunlight, which is spectacularly hard, and try and figure out which way I'm out. But now that I have some fasteners in it, I have a screw in the screen track here, right there. So now that I have some fasteners in it, I'll be able to adjust a couple of parameters on this side, and hopefully the stuff behind me won't be moving around. So, and then out here, we're digging a hole in the plywood, which the framers put on for us very lovingly. And so what we're doing is the intake, I suppose. I'm not sure which way we have it, but there'll be an intake and an exhaust up high. I don't know if it's intake down low or exhaust down low and up high. I don't know how I want it. I suppose maybe I would want the intake higher. Yeah, I don't know. I'm not sure. And then we have the electric service going in here. I got this trough, which is super duper. It's 12 inch by 12 inch. And that's because we're going to put a pair of Solarc 15K inverters on this wall. And I need a 12-inch trough to get them in. And, no main breaker. I got to have a main breaker in there because on the output of the inverters, you gotta have the actual disconnect for the house, which is a little funny because it's like we got a disconnect on the input, but if the fire department were here, they want to disconnect on the output. So what we would do is we would put the main disconnect or service disconnect sticker here so that the fire department would know how to shut off the power to the house. Because with battery inverters, if you shut off the power here, the inverters will draw power from the batteries and then feed the house without the utility power, and it would make it so the fire department can't shut off the power. So I think we'll put a main breaker in this panel, and then that'll be good. So that'll allow me to have 6 strings of PV up to something ridiculous like close to 40,000 watts of panels. So we're going to cover this whole roof, maybe. And then we were also thinking about putting some on this wall. But those are going to have to be micro inverters, I think. AC coupled to the gen input on the 15Ks. So the 15Ks can turn them on and off. But if they're shaded, it won't mess up the strings. Although there probably won't be much shading on the roof. So only on this wall we have shading. And yeah, we're still trying to chase down this drain line. I'm missing a drain line somewhere here. Maybe it's not there, maybe it's there, I don't know, but I'm gonna find it. And we're gonna chop holes in these walls and figure out where they're at. It's not a problem to cut a bunch of holes in these walls because these are not structural walls. They don't have anything to do with the shear value of the building. And secondarily, or also in addition to that, they're literally only here to hold the insulation. So we're just going to chop a bunch of holes in them. And I have a hole already over here above this electric panel because we had to fish an SER cable through the wall. So I have a air sealing penetration to do in there. And so I'm going to do that, and then I'll put this piece of plywood back in the hole. So again, cellulose in all these walls. We're just going to hole saw into every cavity and fill it up with cellulose. So, oh, this is our crating from our windows. It's this 1-inch plywood. It's pine. It's not fancy, but it's been extremely handy around the place. And yeah, so I'm gonna put this lift slide in tomorrow, and I'm gonna get this other one on the office here buttoned up and secured because I'm tired of not having it be perfect. So I'm gonna make that perfect. And then we'll put this one in tomorrow. And this is the front door here. I'm gonna leave this front door out for construction with drywall. All the drywall's in, but it's gonna be a huge mess. So we're just gonna make this, or we're just gonna keep using this temp plywood. We've got all these pieces of wood on here, and I have a piece of plywood right there that fits this hole. So we're just gonna keep using that. And yeah, so that's what we're doing today. Hope that's cool. Oh yeah, you can see some of our insulation going in here. So these windows are recessed and they're surrounded by insulation here at the top. And then we're weather sealing it to the top. We haven't done that side, but we're working on this side. We had to move the scaffold for another project, but we're gonna little tape there in the corner. Again, all this tape on the outside of the house is for wind washing to keep the wind out of our insulation. It's not an air barrier. Plywood can be an air barrier, but it is not on this project. And then these are all done up here. So There's a little over insulation on this column here. And then we're going to put sheet metal over that. And then the exterior. And then the interior. Oh yeah, we cleaned out all these beams off the ceiling. And then we furred down this ceiling to match the height of this 2x8 here. And then we got exterior or interior insulation in here, 3 inches, to add to the thermal performance of that plane. And these are all taped in. At the very top here, I know it doesn't look like it's taped in, but the tape is actually under the insulation up to the plywood right there, that plywood, which is our air barrier. So the air barrier seal goes up to the plywood, and then we over insulated it with this Kingspan we have left over. It's 3-inch Kingspan insulation, and then we packed mineral wool in the gap. So although it doesn't look like we sealed the top, we did do it to the air barrier, and then the insulation is just press fit up in there with the mineral wool. We tried to put as much mineral wool in as possible, just because that's a better way to do things if it's possible. We had this Kingspan left over from the under concrete insulation, so I didn't want to be wasteful. So we've been using it up. So yeah, that's some of the stuff we're working on today. So hope that was cool. Thanks for looking.